What is differentiation? Differentiation is a fundamental concept in calculus that refers to finding the derivative of a function. The derivative can be interpreted geometrically as the slope of the tangent line to a function at a given point. Conceptually, differentiation finds the instantaneous rate of change of a function. Differentiation is about taking a function and finding its slope or rate of change function called derivative. It is fundamental operation in calculus with many theoretical and practical application. Application of differentiation. Differentiation is used for related rate, interval of increasing and decreasing concavity, first and second derivative tests, graphical polynomial function asymptotes, maximum and minimum value of a function, applied maximum and minimum problem, Rolle's theorem and mean value theorem.
Today I'm going to talk about related rates. Okay, first, related rate refer to a type of calculus problem where you need to find the rate of change of one variable with respect to another variable. The key step in solving related rate problem are, okay, first step, we must identify the variable and know the variable you need to find. The problem will give you some variable like the dimension of shape and ask you to find the rate of change of another variable like the volume. Second step, differentiate to find equation related the rate of change. Use implicit differentiate or the chain rule to find equation relating the rate of change of the given variable. Third step, substitute known value, plug in the value given in the problem for the known rate and variable. Fourth step, solve the resulting equation for unknown rates. You now have a equation with only one unknown, the rate you need to find, solve for the variable. And the last step, write your answer in the sentence, identify what rate you found. Next, I'm gonna talk about why we use related rate. First, solving related rate problem help reinforce an understanding of derivative and how they relate variable and their rate of change. It provides practice applying derivative. Second, some related rates problem involve maximizing or minimizing some quantity, bringing in optimization. Solving this help develop skill for optimization problem. And lastly, working through multi-step related rate word problem involve translating a real-world situation into calculus concept and equation. This develop valuable mathematical modeling and problem-solving ability.
Problem statement. Question 1. Oil spilled from a ruptured tanker spread in a circle whose radius increased at a constant rate of 2 cm per second. How fast is the area of the spill increasing after 5 minutes?
So next, let's solve this question number 1. So step number 1, we have to highlight the important information given in this question, which is circle, radius and 2 cm per second. And the last answer, this question wants us to find the area of the spill that increasing after 5 minutes. So number 1, we can define as our dr dt is equal to 2 cm per second, and number 2, our t is equal to 5 minutes. In this question, we have to find dA dt, and we can also create our formula, which is dA dt equal to dr dt times with dA dr. But before that, we have to convert our 5 minutes to second first. Now, 1 minute is equal to 60 seconds, and we can simply multiply 5 minutes with 60 seconds, and we can get our second is equal to 300 seconds. Next, we draw our circle of oil with radius. To find area of circle, we can use pi r square. From this formula, we can find our dA dt, that is equal to pi square. We can put in front of pi, and at the same time square minus 1, and we get r is power of 1, and dr dt. As we know, dr dt is already given in this question, which is 2 cm per second. and we can change our dr/dt, and the last answer we get is 4 pi r. Clearly, we can say that 1 second is 2 cm. So for 5 minutes is equal to 300 seconds, that we can multiply with 2 cm, and we get 600 radian of 5 minutes. So dA/dt is equal to 4 pi r equal to 4 pi 600, and we get our last answer is 2400 pi.
Problem statement, question 2. Water is being pumped into a conical tank at the rate of 100 feet cubic per minute. The height of the tank is 20 feet and its radius is 5 feet. How fast is the level rising when the height of the water is 10 feet?
Okay, so for question 2, how we are going to solve it? First thing, we are going to highlight the important things. So we are going to highlight the conical tank because we are going to know that the water tank is in the conical shape, and then the water is being pumped into the conical tank at the rate of 100 feet per minute, and the height of the tank is 20 feet and its radius is 5 feet. So the first thing is we are going to write what is the information given by the question. The first thing is the question give us the height, which is 20 feet, and the radius, which is 5 feet, and 100 is the rate, so the rate will be dV over dt. And then we are going to solve the question using the formula volume equals to 1 over 3 pi r square h. So we are going to write r over h, which is 5 over 20 multiplied by h, and then it will equals to r equals to h multiplied by r per h equals to 5 over 10 multiplied by h, and then we are going to get 1 over 2h. And then we are going to solve the question, which is v equals to 1 over 3 pi r square h, and then r square is going to be substituted by 1 over 4h. And then for the rate, we are going to write dr over dt equals to pi multiplied by 3 multiplied by 1 over 48h in the power of 3 minus 1 dh over dt. So it will be pi 1 over 16h square in dh over dt, and then dh over dt, if we remember when h is 10 feet, so dv over dt will be pi multiplied by 1 over 16h square dh over dt. So dv over dt is 100 at above, and then it will equal to pi 1 over 16 10 in the power of 2 dh over dt. So we are going to get dh over dt equals to 5.093 or 16 over pi.
Conclusion for this assessment is related rate is a concept in calculus that involves finding the rate at which one quantity changes in relation to the rate of change of another related quantity. This is typically done through implicit differentiation and applying the chain rule. To sum up, differentiation is a strong quantitative technique that is applied in many different fields to stimulate and comprehend changes in one quantity with respect to another. By applying differentiation method, we can identify the rate of change based on the problem given.